Good evening to all. Today's topic digital transformation in construction, handled by Dr. K. Pungodi, Professor, Department of Civil Engineering, Director, CCMM, SR University, Varangal. Digital transformation in construction. Construction industry is evolving rapidly. It shifts from traditional to digital methods. Need for efficiency, safety, and speed. It is a labor-based industry. Lot of scarcity will be there in future for all variety of labors, but any cost not able to stop the construction since in need of increasing from individual residential house to infrastructure construction works like dams, road, airport, and harbors. So here, this is the picture of how the construction site to be improved. So here, equipments are there, management peoples are there, materials are delivered from supplier to site. Here, skilled laborers are there. Collaborative, it will be collaborative. All crew of members to be collaborative. Robots are there in construction. So here all are combined together and connected with the uh, laptop, and from here through the net services we have to connect with the cloud, and from cloud the from remote areas also the management people are able to manage the entire work. So here from anywhere we are able to operate the site. This is the very important advantage of the digital transformation. Here first we have to start with the digitalization, then digital transformation. Digitalized information, here we have to organize the information. So here this conversation of analog assets and process to digital for keeping up with technological changes. Digitalization is converting business process using digital technologies to increase the business efficiency and revenue. And digital transformation, it is an approach to problem solving through the technology. What is digital transformation? It is an integration of digital technologies, data-driven decision making, automation and smart systems, leveraging digital tools to understand customer needs better and improve satisfaction. Why it is matters means the construction process is a lengthy one and it consumes minimum 18 months to complete a project. Even normal small residential project, it consumes more time. No guarantee to complete within the duration because of the climatic conditions, delay in material supply, and lack of coordination among the various group of people. So with the help of the digitalization, we can reduce the project delays, we can improve the quality and enhances the collaboration among all people. Traditional versus digital construction, how we can able to compare with the traditional construction with the digital means, here entire manual process to be automated systems. Here in traditional we are using manual, but digital we can use the machine for the construction like robots, and by traditional we are using the paper, but here cloud based. And traditional approach is reactive. Once the problem arises, after that only we have to react for them. But digital construction is the predictive based. So before problem arises, we are able to judge what may be the problem, how it can be solved, who are the resource persons, what are the resources needed to solve the issues like that before failure, and we can able to identify the issues and solve the issue, and we can reduce the downtime also. So the key technologies are BIM, that is Building Information Modeling, IoT, Internet of Things, AI and ML, drones, robotics. So with this, we are able to achieve the digital construction. BIM, this is 3D digital representation, life cycle management, and class deduction. So here apart from the CAD, we are able to achieve the further advancements. What are the benefits of the BIM means? The efficiency can be maximized. It reduces the cost by reducing the wastage, improved cost estimates, better insights to projects, communication and collaboration is increased, less risk and less wastage, better end results. This is the advantages of the BIM. And the remaining other benefits also, conflict reduction and risk mitigation is very easy. High level customization and flexibility is able to achieve. Optimization of the schedule and cost. Easy to maintain of a building life cycle. Faster drafting without loss of cost and quality. And coordination and collaboration. How the BIM is evaluated means from pencil and paper, hand drawing. It improved to 2D CAD, that is AutoCAD, then 2D to 3D, then 3D to BIM with the help of the Revit and Tekla software. What are the dimensions of the BIM? The dimensions of the BIM is starting from the 1 to end with 10. 1 is the paper and pencil method, so we can directly move to the second one. The 2D is the documentation. So traditional drawings and design communications, everything to be documented. And 3D BIM is the modeling. So the core 3D model aiming design clarity. 4D BIM, it is related to scheduling. So how the entire project can be scheduled. What is the start date? What is the end date? Among that, all the works are converted into activities. Each activities consumes resources. That resources to be uh, listed out, and what is the starting date and what is the end date for each and every activity, and what are the floats, what is the critical timelines, like that we can schedule everything with the help of the 4D. Then 5D BIM, it it gives the cost estimation. Uh, Cost estimation means stage by stage and activity by activity and day to day. What is the cost needed? How much money consumed, like that? We are able to get the data with the help of 5D. Then 6D, it involves is the sustainability. So here, how SDG goals are collaborated with the construction. With the help of 6D, we are able to mix sustainability. Then 7D gives the facility management. It supports the operation and maintenance. Then 8th D involves with the safety. It focuses on construction safety planning and avoids accident. And 9th D, lean construction. It enhances the process efficiency. Then 10D, 10D BIM, it is the construction industrialization. Here it integrates the off-site construction methods like prefabricated methods. So here the construction elements are made at the uh, factories, then after that it is imported to the site, then from the site it can be assembled, then simply we are able to get our structure. That is the 10th D. In India now up to 5D we are able to easily go through them. Then if we are include the SDG, then 6D also can be included, then other steps we have to evaluate. So the benefits of the BIM are improved visualization, reduced errors, better coordination, classes will be easily detected, reworks can be avoided, money can be saved, projects can be completed as per the agreement and the schedule. This is very important benefit we are able to get through the BIM. The next one is IoT, Internet of Things. Here, sensors plays the major role in construction. We are able to monitor real-time things. Then, equipments are tracked and how much work completed, who is the operator, what is the condition of the equipment, like that. Everything we are able to monitor through the IoT. The smart sensors, These sensors in constructions are IoT enabled devices that collect, analyze, and transmit real time data on environmental conditions, structural health, and equipment performance. They enhance safety, optimize energy use, and enable predictive maintenance, reducing costly downtime and improving efficiency. Common types include temperature, humidity, vibration, and motion sensors. And we are able to monitor the structural health with the help of the sensors. The sensors track concrete curing conditions, detect structural variances, and monitor vibrations to ensure the long term stability. Environment and safety monitoring: these devices measure air quality, gas levels, humidity, and temperature on site, protecting workers and ensuring material compliance. Equipment and site management: proximity and laser sensors track machinery and materials, while motion sensors enhance security and manage lighting automatically. Then predictive maintenance: sensors monitor machinery for and identifying variances to allow repairs before the failure occurs. So then the sensors are very helpful in construction. So here, the smart building sensors, how they are work means in the field of security, fire safety, lighting, uh, 24 by 7 monitoring, HVAC systems, and energy management, so that our structures will be protected. We can protect our structures from the fire with the help of the temperature sensors, and by adjusting the lightings, the cost can be reduced. Our asset is always under monitoring, so no need of worry for theft and other things. HVAC systems always to be maintained properly, so with the help of the sensors we can able to maintain it properly. And energy management also, so sensors can save building energy, it improves the sustainability of building use. Real time monitoring reduces maintenance cost, it optimizes space utilization, it enhances the safety comfort of the tenants. And AI in construction: AI in construction is the predictive analytics rather than the reactive analysis. Risk management can be easily managed. Then automated scheduling: so automated scheduling means when one work is completed, then how another work will be started, who are the crew members, what are the materials needed, how the money can be managed, like that everything we are able to see in the screen. So AI is actively reshaping industries across the globe, from virtual assistant managing our schedules to intelligent systems streamlining complex tasks. One sector that can benefit the most is the construction. AI in construction helps with project planning, risk assessment, cost estimation, equipment tracking, safety monitoring, and improving decision making. So here, the main components of the AI in construction are: the first one is machine learning. It gives the predictive analytics for material waste reduction. Another one is generative AI. It optimizes designs for sustainable building layouts. The third one is IoT, the real-time monitoring of structural integrity sensors. Fourth one is AI robotics, automated tasks for precise bricklaying and assembly. So that the construction speed will increase. The next one is drones in construction. Nowadays, drones role is very important in all the sectors, especially especially at construction and railways and military. In these areas, the drones role is very important. For site surveying, initial periods, the site surveying consumes in terms of years to complete all the things. We have to take all the readings, then after that we have to sit at office and we have to do all the calculations, then we have to adjust all the values. Like that, it is a labor consuming and time consuming, but nowadays it is not at all needed. Even within a single day we are able to survey in terms of 10 acres, 20 acres, like that we are able to complete that work with effectively. And progress monitoring, safety inspections also can do with the drones. And railway track monitoring, that is very very important work at the railways. But with the help of the drones, the labor group totally can be reduced, and accidents also can be reduced. And military related works, initially the drones are used only in militaries, but nowadays it is very common, it is used in day to day works. How the drones can work means, at site it inspects them with minimum human effort, inspection of cranes and towers, site planning, 360-degree view of the entire plot. Like that, for all these things we can use the drones. So here how we can inspect the site means, with the help of the drones, the areas marked as risky zones we can use the drones. Instant overview of the entire area we can get, so it saves the time and the effort. Then the important machineries are cranes and towers. uh, so here, suppose sometimes because of the heavy equipments the accidents are happen. So to monitor that, cranes and towers, what is the condition, how much weight it is able to carry, where is the issues, like that simply we are able to carry out with the help of the drones. So the inspection of high buildings has been made easier with the help of the drones in the construction sector. Site planning overviews are obtained quickly to ensure efficient planning. 360-degree view of the entire plant, a vibrant experience to enhance the awareness of potential risk, and also the orientation of the site is able to complete. So, drones are revolutionizing railway operations, particularly in Indian railways, by enhancing maintenance, inspection, and security. They are used for high pressure cleaning of train coaches, inspecting infrastructure like tracks, bridges, and catenary lines, and enhancing the security by monitoring thousands of kilometers of the track without the human beings. Robotics and automation. Bricklaying robots are nowadays used in foreign countries for the construction of the masonry. 3D printing of the structures, for that robotics are used. So totally we can reduce the labor, and dependency of the labor also can be reduced. So here in this picture, we are able to see that how the drones are working at the railway predictive maintenance platform. Here, AI plus drones and robots are combined so that we can monitor the track from the office itself. Here, no need of laborers to check the tracks, and where are the loose connections, where are the issues, like that. Here, suppose we are using the human beings means, the risk is much more, and all the climatic conditions are not suitable for the human beings to work on the railway track. Accidents also very common, but with the help of the drones, by sitting at the office, we can able to see the conditions of the track 24 by 7, easily able to track the railway track. And cloud computing, this is the centralized data storage, real-time collaboration, and remote project access is possible. Cloud computing in construction enables real-time collaboration, instant access to project data like drawings, plans, and photos, and improved management of resources. It removes the need for extensive on-site IT infrastructure, reducing cost while connecting field teams with office staff to enhance safety and efficiency. Cloud for construction. Within the construction project, from initial design through facility management, there are many stakeholders in many locations like architects, construction team, engineers, surveyors, government bodies, and the final client. So, all in different places with different roles in the process. So, with the trend towards more collaborative ways of working, the need to have accessible information for project, we can easily able to share the data and monitor results point firmly towards the cloud solutions. Next one is digital twins. This is nothing but virtual replica of physical assets. So we are able to simulate the real-time simulation, and performance monitoring is easily able to complete it. So here, with the help of the digital twins, we are able to create the virtual 3D models. So in that, how all the things are there, where the beams, where the columns are there, what is the height, uh, where is the exact location of the beam, how the beam column joint acts, like that we are able to monitor all the things with the help of the digital twins. So the type of digital twins in construction are, first, the design twin. It focuses on validating design choices through simulation and early stage analysis. The another one is construction twin. IoT sensors are embedded in physical components like HVAC systems, lighting, and structural elements. The third one is operational twin. It monitors and optimizes building performance, energy consumption, and maintenance post handover. The next one is predictive twin. Uses AI to forecast future behaviors, failures, or usage trends, enabling proactive decision making before the failure. Then United Twin, it combines the multiple systems like HVAC, structural and electrical like that, and into a unified ecosystem for large or complex facilities. The next one is augmented reality. It overlay the digital information on site, so the people are visualize the designs in real space. So the augmented reality in construction overlays digital 3D models onto the physical job site, enabling real-time visualization, enhanced safety, and improved accuracy. By merging digital twins with the real world via headsets or devices, teams can identify design conflicts, track progress, and reduce errors before they become costly fixes. So, before doing the work, before the work can be completed, with the help of the AR, we are able to identify the classes easily. The another one is virtual reality. This is the immersive project walkthrough. We can present to the clients easily, and clients also able to enjoy the 3D views. So walk through into the building is very possible with the help of the virtual reality. So it is a computer generated immersive 3D simulation that allows users to interact with artificial environment using specialized headset for training or virtual experience. So this virtual experience will give about the height of the room, volume of that hall, what are the facilities, where the fan to be fixed, where the AC to be fixed, where the washing machines, where the TV. So like that, each and every small things we are able to walk through before the construction with the help of the virtual reality. So by seeing all the things, even paint colors also, we can change accordingly. So here, this virtual reality helps that before the construction, virtually we are able to walk into the each and every place like staircases also into the buildings. So the ability to virtually inhabit and feel deeply immersed in a new building before construction commences, and it is one of the most powerful use of the virtual reality. So the clients are easily able to compromise, and they can suggest their values, and the relationship between the contractor and the client will be improved with the help of the VR. Another one is big data in construction. The big data means it analyzes large data, it improves the forecasting and optimize the cost. It refers to the vast, complex and unstructured information generated by IoT sensors, wearable technology and building information modeling on modern job sites. By analyzing this data, companies optimize project schedules, enhance safety through predictive risk management, and improve efficiency, reducing the 98% of the data currently lost or unused. So here the 10 B's of the big data. It starts with the value. So construction industry benefits greatly from the big data. The next one is volume. The bulk of the big data enables the development of construction models. The third one is the velocity. The velocity with which big data sources expand can stream construction projects rapidly. The another one is validity. So accuracy and validity of data is crucial for ensuring the usefulness of the big data. The next one is vulnerability. Here big data enables development of reliable construction models. Another one is volatility. Here construction models can vary and change in accordance with the big data sources. Then visualization. Data visualization is becoming complex with the increase in complexity of the data. Then variety. The variety of big data source increases the opportunities for development projects. Then versatility. Here the reliability of the data sources is judged by the veracity. So variability here, lot of data are variable, and all the data can be easily managed with the help of the variability. So the big data is very helpful for the construction people. And project management softwares, a lot of softwares are nowadays in use. For all the softwares, MS Project and Primavera are the basics. Here the softwares are scheduling tools, budget tracking and resource allocation. Top construction project management software solutions for 2026 include Procore, Autodesk Construction Cloud, and Builder Trend, offering cloud-based tools for scheduling, budgeting, and field collaboration. These platforms streamline workflows, manage documents, and improve communication between job sites and offices. Key features include Gantt charts, cost tracking, and mobile reporting. So the top construction project management softwares are Procore, a widely used comprehensive cloud-based platform for managing projects from planning to completion. The another one is Autodesk Construction Cloud. It is the top ranked for connecting teams, data, and workflows across the construction life cycle. Then Builder Trend. It is ideal for residential construction, for focusing on scheduling, client communication, and project management. Then Oracle Construction and Engineering, it offers robust cloud-based solutions for large-scale project control, document management, and payments. Another one is FileWire, known for its strong mobile app for field management and task tracking. Then RIG, a versatile customization platform for suitable uh, for the managing of multiple construction projects and workflows. Then Origo Masterworks Cloud, it is a strong in budgeting, estimation, and resource allocation. Then House Pro, an all-in-one solution for residential design and contracting professionals featuring 3D floor planners. Then BuildOps, tailored for commercial subcontractors, covering service dispatching, scheduling, and invoicing. Then Linarc, a simplified cloud solution for field to office communication, including daily logs and cost tracking. It simply replaces the M-book. Smart construction equipment, they are GPS enabled machineries and automated control systems are uh, there. Then safety improvements, wearable technologies. Nowadays, helmets are not only helmets, they are giving information about the climate and the health of the workers also. And real-time hazard alerts can be given to the workers with the help of the safety improvements. Sustainability and green construction, energy efficient designs, reduced material wastages, carbon footprint reductions also can be monitored. Prefabrication and modular construction. Nowadays, this is very famous. Up to now, the construction industry is on-site oriented industry, and wherever the works are going on, the people want to move to the work site, and we have to stay at the site. That site may be at forest or remote areas or wherever may be. But nowadays, we no need to go like that since it nowadays this is also offsite kind of industry, and offsite is very possible with the help of the prefabrication. So with the help of the prefab, faster project delivery is possible, and quality control is very much improved. So prefabrication involve manufacturing building components at offsite in a controlled factory setting before assembling them on site, and offering 30 to 60 percentage faster project delivery, improved quality control, and reduced waste. While prefabrication refers broadly to any offsite component production, modular construction refers specifically to create large 3D fully fitted sections. So prefabrication is a general term for components made of site, like walls, roof trusses, panels, even beams and columns also. Modular construction is a specific type of prefabrication where 3D units are built in a factory and transported to the site to be assembled like blocks. Then key distinctions, modular systems are often more complete upon arrival with the help of the, which includes the MEP, that is mechanical, electrical and plumbing systems, while prefabricated systems can range from simple components to entire modules. So we have to go through the MEP systems to be included. The another one is 3D printing in construction. 3D printing is nowadays improving a lot. This is the future of the construction. So rapid prototype constructions we are able to complete, and this is the cost effective construction of the buildings. The another technology is blockchain technology. It secures transactions, transparent contracts, and supply chain tracking. What are the challenges in the digital transformation means high initial cost, lack of skilled workforce, and resistance to change. Cyber security concerns, data protection issues, and risk of cyber attacks. So skill development, the need for the digital training, that is very important. Once we know about that, then it will be very easy. So upskilling workforce, we have to give training to each level of the workforce, and it should be improved. Then case study examples in India are smart city projects, then use of BIM and IoT. Nowadays, all the smart city projects are using the BIM and IoT. Even the metropolitan cities, the mega projects are using that all the digital advancements. And government initiatives, Digital India, smart city missions are the initiatives taken by the Indian government. Then future trend, fully automated construction sites and AI driven decision making, so that we are able to get accuracy of more than 95 percentage, and chances for the mistakes are will be very less. What is the impact on engineers because of the digital construction means this field first affect the technical people like engineers. It is the need for digital skills, and it is not, we are not able to avoid them, and role transformation to be ensued. So cost versus benefit analysis. The initial investment will be more, but the long-term gains also more, and the rate of return will improve. So we have to consider all the things, and we have to jump into the new technologies. So improving the rate of return in construction involves maximizing the project profitability by boosting efficiency, controlling costs, and focusing on high value improvements. Key strategies include using digital management tools, optimizing resource allocation, and prioritizing renovations that offer the highest resale value, often aiming for more than 10%. So, how we have to implement the strategy means, step by step we have to go for the adoption, then pilot projects to be constructed, then gradually it should be scaled. So the digital transformation is the future of the construction. Smart infrastructure and all type of structures we have to transform for the digitalization. Thank you for watching.